Well, welcome back. Still working on section 3.5 here, implicit differentiation. Part 2 is basically using implicit differentiation to create other derivatives, such as these lovely derivatives, sine inverse, tangent inverse, secant inverse, etc. So these are 6 derivatives that you should remember. The derivative of sine inverse, as you can see, it's a 1 over. It seems strange because this is a trig function. This is not a trig function. So why is it that the derivative equals this thing right here? And for tangent inverse, why does it equal 1 over 1 plus x squared? Secant inverse, why does it equal that? Good question. So pick one, and then we'll prove it. How about just start at the top, sine inverse? Why does the derivative equal this? So if you want to prove it, start with, you say, okay, I've got this function, y equals sine inverse of x. And I want to find y prime. Well, what you could do with this one, this equation right here, is take sine of both sides. So it would then say sine of y is equal to x. If it's saying sine of y, that means that y is equal to an angle. And you could then draw a right triangle, say this is the angle y, and sine of y, well, sine is opposite over hypotenuse. This could actually be written as a fraction, namely x over 1. Which means since sine is opposite over hypotenuse, the opposite side is x, the hypotenuse is 1. So this is the opposite, this is the hypotenuse. Now I need to solve for this missing side right here. So I need to use some variable. I'll just call it letter a. If you do the Pythagorean theorem, that would say a squared plus x squared equals 1 squared. Or in other words, a squared is equal to 1 minus x squared. And take the square root, so a is equal to the square root of 1 minus x squared. Suddenly, this is starting to make a little more sense. Okay. But we still haven't done the derivative. So then you take this part right here, the sine, and take the derivative. So the derivative of sine will be cosine. Then do the implicit differentiation part, or in other words, you got to do the chain rule, take the derivative of y, that's y prime. And on the right, the derivative of x is just a 1. So my goal was to find out what y prime equals when y equals sine inverse. So solve for y prime right here. Y prime is equal to 1 divided by cosine of y. And what does cosine equal? Well, cosine equals adjacent over hypotenuse. So that's a over 1. Well, we just found out what a equals. So cosine equals adjacent over hypotenuse. That means, these 3 little dots means, therefore, my final answer is the derivative equals 1 over cosine of y, which equals this square root. So that means that the derivative of sine inverse equals 1 over the square root of 1 minus x squared. That is where this comes from. Oops, that is where this comes from. Okay, notice that right here, I only did 3 of these. Because once you have these 3 memorized, then these 3, you get them for free because they're almost exactly the same. So you go across from sine, and its cofunction is cosine. The derivative of a cofunction is negative, and it's going to be negative the same thing. Across from tangent, I put its cofunction, cotangent, and the derivative of a cofunction is negative, the same thing. And then for cosecant, it will be cosecant inverse. It will be the same thing as secant inverse, except negative. Okay, now let me show you some other examples. So for example number 1, using these new inverse trig functions. Suppose that y equals tangent inverse of the square root of x. Find the derivative dy dx. So the derivative for tangent inverse, as I was just showing you on this other piece of paper, it's going to be 1 over 1 plus x squared. Well, that's when this is an x. So basically it's saying whatever is right here, you have to square it right here. So I look at it as the derivative of tangent inverse is 1 over 1 plus something gets squared. That's the derivative of tangent inverse. And in this case, the something is the square root of x. And then don't forget the chain rule. So we also need to take the derivative of the square root of x, which is 1 over 2 times the square root of x. And then let me just simplify a little bit. The square and the square root right here will cancel, so that's going to leave 1 over 1 plus just an x. And then it also gets multiplied with 2 and the square root of x. And there's no reason to multiply this out, just leave it like that. What if it was just slightly different? What if it was the square root of sine inverse x? So when you take the derivative, the outside function is the square root. And use the shortcut. The derivative of the square root is 1 over 2 times that square root. Now do the chain rule. Take the derivative of the inside. And because I have it memorized, I know that derivative of sine inverse is 1 over the square root of 1 minus x squared. And this one can't really be simplified, so it's done. For example number 3, what's the derivative of the natural log of x? Well, this one right here is another one that you could go through these steps, which I'm about to do, each and every time you come across natural log, or you could remember it. So if you remember it, it would go like this. The derivative of the natural log of x is equal to just 1 over x. It's a very easy one to remember, very useful. So I recommend that you remember it and take this shortcut. Just like I remember with the square root, the derivative is, sorry, I'm not sure if it's on the screen. The derivative of square root is 1 over 2 times the square root. Saves me a lot of time right there. So why is it that the derivative of natural log of x equals 1 over x? Excellent question. So what I'll do is I'll exponentiate both sides. So the left side will have e to the y. The right side, e and natural log will cancel each other out, so it just equals x. Then use implicit differentiation, take the derivative on each side. On the left side, the derivative of e to the y is e to the y, but then you also need to take the derivative of the y. On the right side, the derivative of x is 1. So then, solving for y prime will equal, so just divide both sides by e to the y. So it's going to be 1 gets divided by e to the y. And then if you look right here, e to the y is equal to x. So this e to the y can be replaced with x, so it's 1 over x. So like I said, it's easier and faster to memorize this one. The derivative for natural log of x is 1 over x. Otherwise, you could do 1, 2, 3, 4, 5 steps every time you come across natural log. Example number 4 is going to be sort of similar. Similar in that this is one that it's easier to have memorized. Otherwise, you could do these following steps. So what if the function is 2 to the x? Well, this is actually very similar to e to the x, and the derivative of e to the x is just e to the x. So is the derivative of 2 to the x just 2 to the x? Well, let's check it out and see. The first thing to do is take natural log of both sides. The reason that that's the first step is because there's a rule with logarithms that this exponent, you could take it and put it in front and multiply. So that looks like I'm taking the derivative, but I'm not. Right now, that is pre-calculus. So this is an exponent. Natural log of 2 is an exponent. So when you multiply and the bases are the same, you multiply the exponents. So that's from pre-calculus. Now the calculus part. Take the derivative. Okay, so as I just covered, the derivative for the natural log function will be 1 divided by whatever's in the natural log function, or the argument. So the derivative of natural log of y will be 1 over y. Then do the chain rule. Take the derivative of y, that's y prime. On the right side, take the derivative of x, so that would just be a 1 times the natural log of 2. And now solve for y prime. So all we need to do is multiply both sides by y, so it's going to be y times the natural log of 2. And then right here, we know what y equals. It equals 2 to the x, so replace that y right there. So it's going to be 2 to the x times the natural log of 2. So when you have the derivative of a number raised to x, it doesn't really matter what the number is. It could be 7 to the x, 142 to the x. Well, it's going to be the exact same thing. So the derivative of 2 to the x is 2 to the x, but then you have to take natural log of the base. So the derivative of a to the x is a to the x, but then multiply by the natural log of the base. That is another one that I would rather have it memorized and do that in one step rather than having to do all of these steps each and every time. Okay, do we have time for another example? Yeah, I think so. Oh, one other thing. Let's say you have this. I might as well do this example number 5. I was just going to have a passing comment about this, but might as well use it as an example. So sometimes people look at this and they say this means that it's sine to the negative 2 because you have an exponent and an exponent. But the thing is, this is not an exponent. It's written as if it was an exponent, but it's just saying find inverse sine. I forgot to write y equals. There we go. Now, some places, some books, and other people will write this. because arc sine is just another way to say inverse sine. So this is saying the inverse function of sine, but it's written as if it was an exponent, but it's not really an exponent. So some people write it like this. Okay, now to actually find the derivative. So the y prime will equal, take the 2, bring it down and multiply, and then arc sine is now raised to the 1 power because you need to subtract 1 from the exponent. And then multiply by the derivative of inverse sine. And there we go, it's done. Although I would prefer to write it this way. The denominator is square root of 1 minus x squared. And personally, I don't really care for the arc sine. I'd rather write it that way. Okay, that was example 5. Now on to one more example. Example number 6. How about y equals the natural log of secant of x? So on the left side, y prime equals. On the right side, the derivative of the natural log is 1 divided by whatever's in the parentheses. Now do the chain rule. The derivative of secant of x is secant of x times tangent of x. And then these secants are going to cancel, so all that's left is tangent of x. Now, compare that with this problem. If y equals negative natural log of cosine, what's the derivative? Okay, so y prime equals, the negative can stay there. The derivative of natural log is 1 divided by whatever's in the parentheses. And then the derivative of the inside. So the derivative of cosine, that's negative sine. So then these two negatives can cancel, and what's left is sine over cosine. You guessed it, sine divided by cosine, that equals tangent. So it turns out the answers are the same. Were the questions the same? Well, actually, they are. Because with this one right here, this is a negative 1, so you could look at that as negative 1 times natural log of cosine. And then you could rewrite it like this, natural log, and then cosine of x is raised to a negative 1. So that's the rule about from logarithms, that if you have an exponent, you could bring it in front and multiply, or if the number's in front and multiply, you could move it up and use it as an exponent. And then, since it's to a negative 1, that means that it's 1 over cosine. And what's the trig identity for 1 over cosine? You got it, it's secant. So it turns out the questions were exactly the same, even though it didn't look like it at the beginning. Okay, so that's implicit differentiation and inverse trig functions. I'll see you in the next section.